Okay, so we've now learned some of the most common and most important list methods which will give us great flexibility when writing programs, and we'll see this in our coding exercises and projects. But to be self-proclaimed list experts, I want to share some other useful built-in functions and list methods that will come in useful on your journey. And the first function I want to share with you is the built-in len function. Now often we'll need to find the number of items in a list, and another way of describing this is to find the length of the list. Now we can do this by using the built-in function called len, spelt L-E-N. Now len, seeing as it's a built-in function, and just like we've seen with the type function and the print function, is written first. So we can type len and then put parentheses. When we pass the list object into the len function, we get a count of the number of elements in that list. So if I pass shopping_list into our len function, we get a count of 10. And to make things clear, if we had a list which contained two lists of numbers, we do not get a count of the sub-elements. We get a count of the number of elements in the list object that we pass in. So if I were to create a list called fav_numbers, and I was to set this equal to a list which contained two lists, so our first list can be 1, 2, 3, and 4, and in our second list we can have 5, 6, 7, and 8, when we place fav_numbers in the len function, we get a count of 2 elements. Now if we wanted to get a count of the number of items in a sublist, we would first of all need to obtain that list by accessing the element using indexing, and then we can pass this item into the list method. So if we were to type fav_numbers and then pass in index 0 into square brackets, this will obtain a list object, which we know is the first list in the fav_numbers main list object. When we now wrap this code in parentheses and then place len at the start, we get the count of 4. Okay, so moving on, secondly, we have a very useful built-in function called range. Now if I asked you to create a list which contains numbers from 0 to 100, your first thought may be to create a variable and then enter the list of values into square brackets, separated by a comma. And in doing this, you would eventually get the result requested. But this isn't very efficient. Here, the range function comes in very handy. So let's take a look at the range function help documentation. You can see here that the range function is able to accept a single value. Now this value will pertain to the stop value that you want the range to go up to, but not including. So by default, the range function creates a range of numbers starting at 0, when a single value is provided. Another thing to notice with this is that it returns a range object. So if I were to put the value 10 inside the parentheses of a range function and then run the code, we get a range object returned, which clearly isn't a list of numbers from 0 to 9, but we can convert this into a list object by passing the range function into the built-in list function. When we now rerun the code, we get the values from 0 to 9 returned as a list. So two things to note here. A single value passed into the range function will generate a range of numbers starting from 0, and it will go up to the stop value but not include the stop value. The second thing to notice is that it returns a range object, so you will need to pass this into the built-in list function in order to obtain a range of numbers. Now going back into the documentation, you can see we can also pass in multiple values into the range function. So if I were to pass in 2 values, the first value pertains to the start value that we want the range to start from, and if we pass in a second value, this pertains to the stop value. So if we pass in 5, 16 to the range function, we will obtain a range object that starts from 5 and goes up to 15, seeing as the stop value 16 is not included. And if we pass this range function into the built-in list function, it will convert the range object to a list object. And if we look at the result, you can see we get a list of all the values respectively. Now there is one more value that we can pass into the range function. If we pass a third value in, it pertains to the step. For example, if we wanted to get numbers divisible by 10 up to 100, we can get this result by putting range and then entering 0 as the first argument, so numbers start from 0. We can put 101 as the second argument, as we want the numbers to go up to 100. And then we can put 10 as the third argument, which pertains to step. This means our starting number will be 0, and we'll get all the values up to but not including 101, and we'll then get each number incremented by 10 each time, because we have a step size of 10. To see the complete list of numbers in a list object format, we can pass the range function into the built-in list function. So rather than having to type out lots of numbers in a list manually, which can potentially lead to manual errors, we can use the range function to save significant amounts of time. Now we've seen various built-in functions. We've just seen the range function, but now I'd like to introduce the zip function. Now the zip function allows us to quickly combine associated datasets without needing to rely on what are known as multi-dimensional lists, so lists within lists. Now while the zip function can work with many different scenarios, we're going to explore a single example in this video, but it should provide a clear picture. Now the zip function takes 2 or more lists as inputs and returns an object that contains a list of pairs. And each pair contains one element from each of the list inputs. So let's first of all create 2 lists with related data. The first list will contain names of people, so we'll call this variable names, and in this list we'll include the names Jane, Peter, Kim, and Sam. Now we'll create a second list which contains the ages of Jane, Peter, Kim, and Sam. So we'll have the variable called ages, and we'll set this to a list of integers, so 24, 43, Kim will be 32, and Sam 18. Now if we wanted to create a nested list that paired each name with their associated age, we could use the built-in zip function. So let's create a variable called names underscore and underscore ages, and we'll set this variable equal to the built-in zip function, and then we'll put a set of parentheses. Inside the parentheses, we're now going to include the 2 lists that we want to stitch together. So if we were to then examine this new variable, so names underscore and underscore ages, we would find it looks like the following. Now what you're seeing on screen here is a zip object, and it contains the location of where this variable is stored in our computer's memory. But don't let this confuse you. In fact, we've already seen how to turn a different object into a list. To turn this into a list object, we can pass this result into the built-in list function. So let's create a new variable where we'll store the list object. So let's call this names underscore ages underscore list, and then we can set this equal to the built-in list function, and inside parentheses we'll type names underscore and underscore ages. Now if we print out the variable names ages list, you can see we now get a list object, and inside this list object we get the pairs which represent the name and age of each person. Now 2 things to notice here. Our dataset has been converted from a zip memory object to an actual list, which can be seen by the square brackets. Now our inner lists don't use square brackets around the values. Now this is because they have been converted into what are known as tuples. And without going into too much detail now, it's basically a list, but it's immutable in nature, i.e. they can't be changed, and we'll cover the concept of tuples in a separate section. So the zip function allows us to take 2 individual lists or more lists with related data and then stitch them together by creating pairs of values. So the first value of each list is included in the first tuple. The second item in each list forms the second tuple, and so on. Okay, great, so moving on. The next method I want to share with you is the index method. Now the index method will return the index value of the first occurrence of the value you stipulate in the method. So let's observe how it operates with an example. So if I had a variable called fav_numbers, and I set this equal to a list of numbers, so 1, 2, 3, 4, 5, and then 6, 7, 8, 3, and 9. If we wanted to find the first occurrence of the value 3, we can put this into the parentheses of the index method. And you can then see that we obtain the index value 2, which we know is the case because 3 is our third element in this list. Now we can pass in a second argument into the parentheses, which represents the starting position of the method. So if we wanted the search to start at index 3, i.e. the number 4, we now get a result back stating that 3 is observed at index 8, as this was the first occurrence of the value 3 that occurred from index 3. So you can use the index method to find the first occurrence of the value that you pass in to the parentheses. And finally, the last method I want to share with you is the count method. Now we call the count method in the same way as we do with all methods using dot notation. Now the count method will allow us to obtain the number of observations for a specific value within a list. So if we had a list of numbers as follows, and once again we'll call this variable fav_numbers. We'll set this to a list equal to 1, 1, 1, 2, 3, 4, 5, and then 6, 6. If we now use the count method on the fav_numbers list object, and then pass 1 into the count method parentheses, you can see we get a result of 3, as there are 3 1s in our list. So here we've observed 3 more built-in functions and 2 more list methods. Practice each one to make sure you understand how they operate, as you never know when they'll come in useful to address specific problems you come across in your coding journey.